think we are ready to go, aren't we? Welcome. Good afternoon here in Sweden. I'm really happy to be part of TechDays 2017 and talking about the topic that is really close to my heart. I'm Rainer Stropek. I'm a passionate .NET developer from Austria, so I had quite a trip to come here to Stockholm, and I really enjoy my time here. Let me ask you a few questions before we dive into the topic. Who would say she or he is a professional .NET developer? Okay, that's good, because we are going to take a look at some .NET code. Not a lot of .NET code. The focus is on Dockerizing your .NET applications. So this is, if you are not that deep into .NET, that's perfectly fine, because we'll focus a lot on the Docker stuff. And that brings me to my second question. Who would say he is an experienced Docker user? Okay, just a few. Who hasn't really put his or her hands on Docker at all yet? Ooh, okay. A lot of people not familiar with Docker. So maybe we'll do a very short and quick whirlwind tour through Docker at the beginning, just 5 minutes. So those of you in the room who already know Docker very well, please excuse me in the first 5 minutes. I will probably tell you not very many new things, but after these 5 minutes, we're all on the same page and we can start. In this session, we're going to do demos. This is essentially my last slide. So after a short introduction, we will dive right into the first demos. Okay. It's always interesting for me when I visit the session, it's always interesting for me to see what is the environment that the speaker is using so that I can try and experiment with the same demos as the speaker did on stage. And I, for my part, am using here a system, of course, with Windows 10. And if you want to try and develop with Docker, you should really install Docker for Windows. You see it down there. You see the nice little Docker whale. You can install it. You can grab it from Dockerizing, from their website. It's the community edition, so it's free and it's open source. That's one thing. What Docker for Windows will give you is a Hyper-V VM. Let's kick off Hyper-V, and if I take a look here, you will see that a Linux VM is running on my Windows 10 box. Inside of this Linux VM, we have a very, very small Linux operating system, an Alpine Linux, where my Docker host is running. So when I'm running Linux containers, they are in fact running inside of a virtual machine running a Windows kernel, a Linux kernel inside of this VM. You don't have to care for this VM. Docker for Windows will install it for you and will maintain it for you. So if you are a .NET developer and you are not that much into Linux administration, absolutely no problem. Just get Docker for Windows and everything's fine. The other thing that I really like about Windows 10, about recent versions of Windows 10, is this guy here. It's the Windows Subsystem for Linux. So I'm using this thing a lot. So I installed the Windows Subsystem for Linux on this box, and that essentially means that I can run an Ubuntu, native Ubuntu, with the bash shell sitting on top of the Windows kernel. So if you see that one, that's not a container, that's not a VM, that's Ubuntu and bash directly talking to the Windows 10 kernel. So I really like the bash shell, and therefore I'm also speaking with my Docker host a lot from bash, but I don't need a VM for that. So I really encourage you to take a look at that. If you want to go into Docker and play with Docker, try it from the bash shell. It works from the command shell and PowerShell too, but if you want all the nice things like statement completion and so on, they only work in bash. So Windows 10 is really a great environment for that. By the way, did you know that one? If I'm in a folder here in Windows Explorer, you probably all know that I can hit CMD and I will get a command shell. But did you know that I can now just type bash and I will get a bash shell in Ubuntu directly in that directory? I really like that. That's really useful if you work a lot with this whole Docker stuff. Yes, and of course, last but not least, I promised you to also show you how you can build your .NET applications and build Docker images from your .NET applications inside of VSTS. So what I have brought here is a VSTS repository. It contains already some demo code that I will introduce in a second, and we will use this VSTS repository to do some Docker build and release automation in VSTS. So that's essentially my demo environment. Next step. I've prepared two very small ASP.NET Web APIs application-ish something. Let me quickly open one of them. The first one that I'm going to show you first is .NET Core. It's .NET Core 2.0, and as we really want to focus on Dockerizing your .NET applications, I stripped that sample down to the very minimum ASP.NET application I could think of. It's essentially a one-liner. It's really a one-liner, which just says, hey, create a website and handle each request and just answer each request with hello world. That's all this thing does. It's only ASP.NET 2.0. Please imagine that your application is somewhere inside. It really doesn't matter for Dockerizing the application whether your application consists of hundreds of source files or just of a single line of code. At the end of the day, it's just .NET. And so I came up with this very simple example here. This is the example for .NET Core, but we don't only want to take a look at .NET Core in this session. We also want to take a look at Windows Container. Yes, you heard correctly. There are Windows containers on Windows 10 and Windows Server 2016. And so I created a second sample. Let's take a look at that one. It's .NET 4, and it's using OWIN, the Open Web Server Interface Library, ASP.NET for OWIN, and it's nearly exactly the same application. It's just a very simple startup class, and you probably guessed it, it answers every request with hello world. So these are the two demo applications we want to Dockerize. Again, please imagine that this is your huge ASP.NET MVC or Web API stuff that you want to put in a Docker container. Okay, nice. These are my demo apps. Now, let's start with the .NET Core and the Linux stuff. The important thing with Docker and .NET, the most important one, we said we make a whirlwind tool through Docker. For those of you who haven't seen Docker, it's very simple to describe why Docker is really nice. Imagine you want to run a new, I don't know, Ubuntu VM to do something interesting. You can just say Docker run interactive Ubuntu. And if I hit enter, I will not get, I should have gotten, that's not very nice. Internet was here a minute ago. No internet in the wireless LAN, exactly now. Okay, let's wait until this guy recovers. Let's do a troubleshooting here, no problem. I can tell you why I really like Docker. The thing is, Docker, for those of you who haven't taken a closer look at this guy, Docker is no longer hardware virtualization. It's virtualizing the kernel. And therefore, if you want to run a Docker container, you can spin up every container, an Ubuntu image, a Debian, a web server, whatever you want to run, within milliseconds. You can spin up a new instance of an Ubuntu server within 200 milliseconds or something like this. And this is really interesting. That means that you can even work with very short-lived containers. You can spin up a container to just do, for instance, the .NET compile step or the .NET publish step, or very short-term things. This is one of the interesting things about Docker. And the other thing that is really interesting about Docker is the Docker Hub. I would love to show you Docker Hub, but currently I don't have internet. So we'll try to get this corrected. I can also try my mobile phone as a fallback internet connection, but let's See, the Docker Hub is a huge collection of ready-made images, just like GitHub for source code. And you can use this Docker Hub collection of images, pull down ready-made images for Node.js, for IAS, for SQL Server, for MongoDB, for PHP, for whatever you want to do. Gateway not available. And you can, once you pull it down, you can start it immediately. You can start using it immediately. And fortunately, for us .NET developers, Microsoft also created a lot of images, especially for .NET on the Docker Hub. Now, let me do the following. I will try to turn on my hotspot on my mobile phone. It's hard to do a session which is bound to cloud computing without the cloud. I have some local data. I'm not sure how the connection is down here. I'll try. Hey Magnus, thank you for that. Yeah, here it is, here it is. Okay, this is the Docker Hub, and now I can show you, hopefully, the demo. Let me see. Let's open that one. Docker run interactive Ubuntu bang, and let's see if it works. Probably Docker has also given up because of the network change. I'm very sorry for that, but I give it one more try, and if it doesn't work, I will use my offline content, and we just have to take a look at the source code, and you will not see the demos. But still, the content should be valuable. You should at least see the source code. I restart Docker, and you see the nice little whale here is loading containers. Technically, in the background now, the Hyper-V virtual machine has been stopped, and now the Alpine Linux is starting again in the Hyper-V container. And with that, Docker is running. Let's do a Docker info. That looks good. And now I'll say Docker run interactive and start an Ubuntu bash, and here it is. Did you see the performance of spinning up this virtual machine? And that's really the nice thing of Docker. I can now hack around in this container, and it's a short-lived container. If I exit it, because of the RM switch here, it's immediately removed. Not like a heavy weight virtual machine that takes minutes to boot and that takes minutes to get rid of it again. It's really a question of milliseconds to spin up such a container. And now let's go into the Docker Hub. If we take a look at the Docker Hub, we have Microsoft.NET. We have the most important image for us as developers, and this is called Microsoft/.NET. This is the image that we can use to build and run .NET applications inside of Docker. Let me show you how that works. Let's quickly spin up Docker run an interactive Microsoft.NET, an interactive Docker container based on Microsoft's ready-made Microsoft/.NET image. So I don't have to care about installing the .NET SDK and the .NET runtime and all this stuff. I don't have to care about providing the binary prerequisites for all this stuff. It's a long checklist that I would have to follow if I don't have this container. But with this, I get from Microsoft an official build. It's a Debian Linux behind the scenes with all the necessary things installed to run .NET inside a Docker container. And let's run a bash. Let's create a directory here and say .NET new web, for instance. If I run that, now I'm using the pre-filled SDK, the .NET SDK that Microsoft embedded in this Microsoft/.NET image. And now I can say .NET run, and it should compile and run the application inside of the container. So this is now technically running an application inside of Hyper-V, the Alpine Linux, Inside of this Hyper-V, a Docker container is running. The image was not created by me. I've used the image from Microsoft. And inside of this container, my application is running, and currently it's listening on port 5000. But this port 5000 is only accessible from within this container. I will show you later how we can do a port mapping so we can access this IP and this port from outside. This depends on your environment. If you're running a standalone Docker host or a Kubernetes cluster or something like this, in my situation currently, it's only running inside of the container. Let me spin up a new bash here and say Docker PS. With Docker PS, I see a list of running containers, and this is the container that I currently started. And with Docker exec, we can start processes inside a running container. So what I can say is I can say Docker exec inside the container. These containers always get very funny names, as you can see here. Of course, you can specify your own name, but it generates funny names if you don't specify a name. And then we want to run a curl HTTP localhost port 5000 and do it silently. And it says, you see, hello world. So what I did, I used my Windows subsystem for Linux to talk to the Docker host inside the Hyper-V machine, to start a process inside of the container in this Hyper-V machine, to do a curl statement accessing my .NET application that runs inside of that container. You get the idea? So what you have seen now is that it is super simple to quickly use Microsoft/.NET to create a new application, build it, restore all the NuGet packages, run it, and as you have seen, it really works. We can do a curl and everything's fine. So let's get rid of this guy. Docker remove forceit 77e and goodbye. Now, yeah, looks good. So this is essentially this Microsoft.NET stuff. But let's take a closer look, because the Microsoft/.NET image comes in very many different flavors. The first one is the version number. As you can see, you can use .NET Core 107, 114, or 2.0. So Microsoft provides different versions of .NET Core for you to use, and you can decide which version of the image you want to use. In my case, I was just using the latest one, and if I look for the tag latest here, then you can see that latest is an alias for the version 2.0.0-SDK stretch. Stretch is the version of the underlying Linux operating system that this image has been built on, and this is the version of the SDK. So what I'm using is a Debian stretch Linux with .NET plus SDK installed on it. Okay, this is what I'm currently using. So let's take a look at this image. Docker images and do a grep Microsoft.NET. Okay, let's take a look. Here is the SDK, and yeah, this is the latest one. And you can see that this thing uses logically, not physically on my disk, 1.64 gigabytes. Why so large? I mean, 1.64 gigabytes is not that large. It includes the Linux operating system plus .NET SDK. Okay, so it's not that large, but still it's a gig. It's more than 1.5 gigs. The reason is the SDK. It comes with the whole SDK installed and all the tools and so on. That's nice for creating apps, for building apps, for restoring apps, for publishing apps. But it's not okay for running apps in a production way. So there has to be something else. And if we take a closer look at the different images, you will see that there are other flavors of .NET here. For instance, we see that there is a flavor which is called runtime. See that one? It's just called to runtime Jesse, or to somewhere it should just say runtime stretch. Yeah, here is the runtime stretch, is the runtime stuff. With the runtime image, I don't get all the SDK stuff. I only get .NET, the runtime, plus the binary prerequisites. So if I want to run a .NET application, not compiling it, if I already have a DLL, then I can use the runtime flavor of Microsoft.NET. And let's take a look what that looks like. Here is the .NET runtime. You see the difference? That's a difference. That's just 200 megs of Linux plus .NET. Okay? That's the whole operating system included. But there is even one thing that is more resource friendly, which is the runtime depths. Depths stands for dependencies. I'm not sure how deep you are in .NET Core. In .NET Core, you can compile an application to be framework dependent. Framework dependent means that you get a DLL and you need to install the .NET framework on the target machine, otherwise your DLL will not run. But there is also a standalone deployment. Standalone, a self-dependent SDD, self-dependent deployment. Self-dependent deployment means that you publish your application so that on the target machine, you don't even need .NET. You bring .NET with you, okay? You deploy .NET plus your application in a collection of some 100 files in a folder, and you can run it without having .NET ever touch this machine. The only thing that you need are the binary prerequisites, a bunch of apt-get install libraries, packages that you have to install on the Linux machine, and everything's fine. So, if we take a look at the runtime depths here, it should be somewhere, here it is, then we get down to 153 megs logical size of operating system plus all the prerequisites. The only thing that you have to add to this guy to run your .NET Core application is your application. The folder that .NET generates if you run .NET Publish. Okay? So let's take a look how this works in practice. I've prepared all 3 samples and we are going to take a closer look now. The first one is this Docker file here. I'll zoom in so you can follow better what I do. In that case, I'm building a new image on top of Microsoft/.NET SDK. So this is the large one, the 1.6 something gigabyte image. It contains the SDK plus the runtime. The only thing that I copy in here is the csproj file and the C# file. I'll show you that here. It just contains my csproj file that you see here and my source code. In my very simple example, the entire source code consists of a single file. So I take the csproj and the CS and I copy it into the new image. And then I do a .NET restore and I do a .NET publish and I even publish the release version of this application and I publish it into a folder which is called out. So what I essentially do, I copy the source code into the image and do the building and publishing and restoring inside the image. And once this container comes up, I use the .NET runtime to start my ready-made DLL. This is possible, but not very smart. Why isn't it smart? I don't need the SDK when I have compiled my application. I don't need the source code inside my image once I have compiled my application. So this works, and it's a nice first step. And it's nice to demo the very concept of ready-made images of the Microsoft.NET image. Let me show you a small script that I've created here. This just copies some source code, it doesn't matter. The important thing is here. What I'm essentially doing, I'm building the Docker file. This is the Docker build step. It uses the Docker file that you have seen a few seconds ago to build an image, which I call rstropek td sweden linux dev. And then it runs the container. But this time, it has a very special switch here. It has the -p switch, and the -p is a port mapping. So what I do is I publish port 5000. It's the port that my application listens to. So I can use localhost 5000 to access my application. And this is what I do down here. I do a curl localhost 5000 something. It always will answer with hello world. And then I will remove the container again. Let's try this. What I typically do is I run these things directly here in Visual Studio Code. What you see here is Visual Studio Code. Did you know that Visual Studio Code has a nice terminal built in? PowerShell terminal, most of you probably know. But did you know that you can change the properties, the settings of your Visual Studio Code so that it will use your Windows subsystem for Linux and offer you a bash shell directly inside of Visual Studio Code? That's a really nice one, because with that, I can do something like Docker info, and I can do all my Docker commands directly in Visual Studio Code, and I can also run bash scripts, like the one you see up here. Let's run it. It's called build. Oh, I have to cd into my directory first, and then use the build sh. Now, let's take a look. It built the application. Now it's doing the .NET Publish, as you can see. So it's running the build engine. Let me zoom in. It's running the .NET build engine inside the Docker image or container, the temporary container that will build the image. And at the end, it started, as you can see here, it started the container. Then it did the curl, so the application really worked. It started the container, and at the end, it removed the container again. So now, if we zoom out and we say Docker images, td Sweden, grep of course, we will see that we now have a ready-made image, which is approximately 1.64 gigabyte, that contains the operating system, the .NET runtime, the .NET SDK, our entire source code, plus the compiled version, and we can start containers based on this image. Not very efficient, but it works, and it was a nice first step. Okay? So let's take a look at the second step, because hey, we are professional developers, so we want to do it in a more robust way. This is the second Docker file that I prepared for this talk. And the interesting fact about that Docker file is the multi-step build. What you see is you have inside a single Docker file multiple from statements. We are using the SDK image to do the NuGet restore and to do the publish. So we are using the ready-made image from Microsoft to do all the necessary compiling. But then we get rid of this guy. We don't use it at runtime. We use another from, and in that case, I'm using another image, ASP.NET Core, which is built on top of Microsoft/.NET. It just has a bunch of ASP.NET stuff pre-installed. Doesn't matter, the details are out of scope of this talk. Essentially, in your mind, it's just the Microsoft/.NET image. But this ASP.NET Core has no .NET tooling, no .NET SDK. It's really only those things that you need to run a published .NET application. So in that case, I'm using ASP.NET Core, and I'm copy, and please note that one, copy the app out directory from this image up here. So I'm spinning up a container, doing all the necessary continuous integration work inside of a container, stopping the container again, but keeping the image, which is called build.env. Then starting a new container based on the ASP.NET Core image, copying the result of the build process out of the first container, copying it into this app out directory, and then again, I'm running just .NET. I need the .NET runtime, because this is not a self-contained deployment, okay? This is a deployment that needs the .NET runtime on the target system. But still, yeah, it should work. Let's try it. Let's run the build again. It's rather fast. It started the guy, and if we are lucky, it should say hello world. Yes, we have proven that it works. And if we say again, Docker images grep td Sweden, and if I zoom in a little bit, you see this is the guy that used the huge image, Microsoft.NET, and this is the one that just uses the .NET runtime without any SDK stuff. And do you see the difference in size? Well, if you run .NET Full Framework on top of Windows, I will show you in a second, you can only dream of these image sizes, okay? We're going to talk about a Windows Server core with 10 gigs at minimum. And here we are talking about an operating system plus runtime of 280 megs. So that will save you a lot of VMs, and that will save you a lot of money in Azure, for instance. Okay? So this is nice. Can we improve even more? Yes, we can. Let's take a look at the self-contained deployment. Can't get rid of that one. The self-contained deployment uses the exact same mechanism as we have seen before. So it uses the Microsoft.NET SDK image, but please note that one here. The architecture switch inside the .NET publish command. The architecture switch makes .NET spitting out not just the DLL, but the DLL plus all the necessary things that you need to run this application. So this includes even all the necessary pieces of the base class library. This includes the common language runtime and all this stuff. So you get a folder that you can essentially put on a USB stick, give it to your friend, and your friend can run it. However, it's self-contained, and that's important because it's architecture dependent. You cannot take this folder if you build it with the architecture Linux switch and run it on a Windows system. This is possible for the framework dependent stuff. So the version 2 that I showed you, you can take this DLL and you can run it without any change on Windows and Linux, on a Windows container and on a Linux container. The result of this build step can only be run on Linux. Otherwise, I would have to change this guy to Win something, okay? But we want to run our .NET Core in this demo on Linux, so this is perfectly fine. And you see that now I'm using the smallest available ready-made image from Microsoft, which just contains the runtime dependency. No .NET. And I do not use the .NET executable anymore. There is no .NET executable. I get a native Linux executable, and it has everything built in that I need to spin up this web application. Okay? Let me quickly show you how this looks like if we go into the .NET Core sample here, and if I run bash here. Oh, this is a little bit smaller, it doesn't matter. Let me quickly build this guy. I will build it locally so I can show you the difference. Give it 10 or 20 seconds or so. We will get two folders here, a framework-dependent folder and a self-dependent folder. Any questions currently? Nope? Okay. Oh, in the meantime, we can run the Docker file that you have just seen. Let's do the build. So we can compare the different sizes of the images. It should run rather fast. You see now it's currently building this stuff and publishing the self-dependent deployment for the Linux target architecture. It takes a few moments because, as you will see, it generates some files, not only a single DLL, but some files. I'll show you in a second how many files. Lots of them. If you are like me, doing half of your work in the Node module, in the Node world, do you remember the Node modules folder? Yeah, this is something similar like that. Okay, and it should say hello world. Here it is. And if I run the grep again, you will see that we started with 1.64 gigabytes. We came down to 280 megabytes with a framework-dependent deployment, and a self-dependent deployment came down to 252 megs. That really now contains only those pieces that we really need. Microsoft didn't install any kind of the .NET SDK or runtime. We brought it with our own application. And now it's finished. You see, here you see the difference. Let's take a look at the framework-dependent stuff. Essentially what we got is we got a single DLL with some configuration files, a lot of JSON stuff. But this is essentially what we got, a DLL, nothing more. And we can run this DLL by saying .NET DLL, and that's it. Okay? Now let's take a look at the self-contained deployment. And as you can see, we got a bunch of files, okay? So this is the whole .NET stuff, and if we sort this one, then we should see somewhere after all this DLLs, where is it? Here we see our executable. This is our small little executable surrounded by hundreds, approximately 500 files that make up the .NET framework, the .NET Common Language Runtime, and everything this application needs to run. Okay? This is self-contained. So we have seen 3 different ways of using Microsoft-provided base images, Microsoft/.NET, and now you can decide what you want to use, which way you want to go. I encourage you not to go the first way. This is perfectly fine during development if you want to keep it simple, but if you want to do it in a robust, production-ready way, you shouldn't go that direction. You should do the self-contained deployment, or at least the second way with the framework-dependent stuff and the multi-step build. Okay, now let's shift gears and switch to Windows containers. If you run Docker for Windows, you will get support for Linux containers and for Windows containers. And if I switch to Windows containers, Docker will take a few moments until it's ready, and then we can play around with Docker for Windows. Let's start a bash shell again. I really love this demo, by the way. If I say Docker info, then you see we are now directly accessing the Docker SDK, the API provided by Windows 10. So now we don't have any VM running Linux or something like this. We have in our Windows subsystem for Linux the original Docker CLI, the command line interface, talking directly to Windows 10, and we can use exactly the same CLI to now maintain, build, run, and everything Windows containers, no longer Linux containers. I really love that. So it's important for me to only have to know a few tools, and this is important for me so I can stick with my bash shell, I can still use my bash shell, I can still use the same CLI, I can still use the same commands, but underneath the hood, everything has changed because we're now running Windows. You had a question? Thank you for asking these questions. Yes, you need to run a recent version of Windows 10. The latest version, I think it was the creators update when this first came out, and the latest version added some additional features. So you have to use the latest version of Windows 10. You don't need an insider build or something like this. You can stay with the production version of Windows 10. It will work very nice. But be prepared that in that case, Windows 10 only supports so-called Hyper-V containers. You will see that in a second. If you start a Docker container, a Windows Docker container on your Windows 10 machine, what Windows will do behind the scenes, it will start a Hyper-V machine with a minimum Windows kernel and run your container inside of this dynamically allocated Hyper-V. It's not a fully blown Windows server that Windows will start for you. It's a minimum Windows kernel that the Windows 10 will start here. It is just there to serve as a Docker host. Okay? If you run, and that's the second part of my answer to your question, if you run Windows Server, for instance, inside your data center, in Azure or any other cloud environment, you can directly use the server's capability of supporting containers. So there you can run containers as you are used to from Linux. You don't need Hyper-V for that. You're just virtualizing the operating system kernel. If you start a container, and inside of the container you start the process is really started on the host's operating system. You can even see it if you run the task manager. You can see the processes inside of the container in the host's task manager. That's the whole idea of Docker. It's operating system virtualization. Okay, it's just namespacing, not hardware virtualization. But on Windows 10, you always have to wait a few seconds more because under the hoods, it will start a separate Hyper-V image. Okay, you don't see it if you start Hyper-V Manager. It's behind the scenes, but it's there. Okay. I will not go into the details of Docker for Windows here because this is not the content of the talk, but I hope I answered your question. Thank you very much. Okay, let's take a look at that one. The next sample here is again a Docker file, and this time it's for Windows, and it's going to be very, very complex. That's it. Okay? Why is it so short? The answer is Microsoft did all the hard work for us. Microsoft provides us with a ready-made image, Microsoft/ASPNET. And this time, note that it's not called ASP.NET Core. It's just called Microsoft/ASP.NET. Let's take a look at this guy in the Docker Hub. Here is the Docker Hub. Let's do that one. And here it is, ASP.NET. And what you will see is a nice little Docker image, multiple Docker images, again supporting multiple versions. So you can choose between .NET Full Framework 3.5, 4.6, and 4.7. Okay? These are official images, so they are provided by Microsoft. It's essentially a Windows Server core. We can even take a look at the Docker file. We can take a look at that one. This is the Docker file, so this is the work that Microsoft did for you. I will not zoom in, but it uses behind the scenes a Microsoft/.NET-framework stuff, and it does a bunch of PowerShell and add Windows features and invoke web requests, doing some ngens and magic stuff. I don't care. The important message here is Microsoft gives you ready-made images for running .NET framework applications on Windows. You just have to copy your files into the right direction. Our good old friend inetpub.root. This is where IIS will look for the application, and that's it. Do you want to do some additional customizing, add some additional components? I don't know, configure IIS or whatever? Just say run and add any command line, PowerShell, whatever, DISM, calls, fancy stuff. You can customize the image to what you really want, okay? But in our case, it's just a .NET Framework application, and the only thing that we have to do is copy it in, and IIS will do the rest, okay? Let's try this. Let's take a look at the build script for that guy. This time, I didn't write a bash shell. This time, I just have a command line shell. The important thing that I really want to show you, let me do it this way, is that you don't have to learn two different things. And I personally think that Microsoft in that area did the perfectly right thing. On the right-hand side, you see the Linux stuff. It's Docker RM and RMI and build and run. And if you know Docker, you are already familiar with these CLI commands. And now take a look at the left-hand side. How much new things do I have to learn if I want to run it on Windows container? Answer, none. It's exactly the same. It's the same CLI. You could even build it from Linux. You can even build it from a bash shell. You don't even need a Windows command shell. However, we are here on Windows, and it feels a little bit more natural when we are on Windows. If we do it on Windows here, this is our Windows stuff. And let's take a look at what this does. It again builds the Docker file just as before. We don't do the building of the application inside of our script here. I copy the ready-made MSBuild output. So inside my original sample with .NET Full Framework, I just call MSBuild. If you want to take a look, it's here. And this is the MSBuild statement, which does on the command line all the necessary building. Of course, you can use VSTS or your build agent or whatever you want to use to run MSBuild. It just takes the output DLLs, copies it into a folder which is called app, and from there we copy it into the IIS, into the container. Let's try it. Build CMD. These are all the DLLs that you have seen here that came out from MSBuild. And here you see the exact same output we saw earlier. Now it's starting the container. And what you see here is a typical behavior. It's not as fast as the Linux stuff is. Even on my Windows 10 machine, it takes a few seconds until my Windows 10 machine will spin up the container. But if I now say Docker PS, I will see that I now have a Windows Server container running on my Windows 10 box. And I output the IP address here. And if we are very lucky, I can say this guy, and let's see. Come on. I want to see hello world. Here it is, hello world. This is a Windows container running on my Windows 10 box with exactly the sample that I've shown you before. Now, do you want to know how large it is? Docker images. Here it is. TechDays Sweden. Yeah, that's a fact. So, you now have a reason to learn .NET Core and to migrate your applications to .NET Core. It will save you a lot of data center space and a lot of money in Azure. Okay. Any questions so far? Yep. Very good. We have a last topic, and we have 10 minutes left, and that's perfectly fine. Because, of course, we have now seen that it works nice with building all this stuff inside of Docker containers, but to be honest, we want to have a professional continuous integration platform. How does this all play together with VSTS and building all this stuff in the cloud and so on? And this is my last demo that I want to show you. I have put it in my abstract, and so I really want to show you how we can do that. The important message in this last demo, where is my, here it is, hub.docker.com, is that Microsoft doesn't only provide you with the images for .NET, for ASP.NET, for ASP.NET Core, and for .NET Core, but also for a VSTS build agent. So there is a ready-made image with all the necessary stuff installed that you can just run on your local laptop or in your data center on a server, and it will connect to VSTS. So VSTS will only orchestrate the build and release and so on, but the build agent will run inside of a Docker container in your environment, and you don't have to care for installing the agent, upgrading the agent, keeping it alive, petting it, and making sure it has enough food and so on. It's just prepared from Microsoft. If there is a new version of the VSTS agent, no problem. You just say docker pull Microsoft/VSTS agent, and you get the new version of the VSTS agent. Do you want to customize it? So you have special components on this build agent, no problem. Write the Docker file, let it base on this Microsoft VSTS agent, and add a bunch of run statements, for instance, and customize it to whatever you need. Okay? I have already pulled down the VSTS agent, and we're going to start the VSTS agent on my Windows 10 box. And in this case, I decided to run it based on Linux. Let me quickly switch back to Linux containers. See if it works. Docker info. Yep, we are back on Alpine Linux. That looks good. And somewhere I should be. This is the wrong one. I don't need that one. Let me quickly clean up here a bit. I don't need that one. I don't need that one. You know what? Let's start a new one in this folder, bash. And let's enlarge the font so that you can follow along. Okay. What I created here is a very short bash script. It just does a Docker run, but it contains so many command line arguments that I prepared it before I started with this session. Essentially, it contains the name of the VSTS account. This is my demo account. Then it contains a so-called personal access token. Yes, you can take a photo. I will delete this personal access token immediately after the presentation. It's just a demo environment. And this is the interesting thing here. It's that one. It does a volume mapping, but in that case, I'm volume mapping a socket. That means that the build agent running inside the container can access the Docker host that the container is running in. You get the idea? So I'm allowing the build agent to access the Docker host on which it runs. And that allows the build agent, for instance, to publish images on the Docker environment that I'm currently working on. You get the idea? Approximately? It can access the Docker environment. Let's make it simple. Let's start it. It will download the necessary software, the VSTS agent. This should hopefully only take a few moments. It's depending on my poor mobile phone. Downloading some bytes here. Any questions in the meanwhile? We will not wait. We will immediately take a look at the VSTS environment and let's see whether we can see this agent in VSTS. Okay, it's still downloading. What you see here is, this is the strange name of my build agent that I created before I started the session. You don't have to do anything in VSTS. You just have to specify the parameters that you just saw. They are nicely documented in the documentation and start the VSTS agent. It will automatically find its way to VSTS, connect to VSTS, and tell VSTS, hey, I'm there. What it additionally does, it looks into its own file system and finds out which capabilities it has. And the pre-configured VSTS agent from Microsoft has, for instance, .NET Core installed. So it can automatically compile inside of this container .NET code. And that's really nice. Okay? You don't have to install .NET. Okay, I got a new one, this one, the EA I don't know what, and we can disable that guy here. So that means that we should somewhere here see, yeah, listening for jobs. Now I have a container running on my Windows 10 box, a Linux container, that hooked up to VSTS and is now ready to compile .NET applications and do crazy things with it. It can, for instance, publish it, self-contained deployment. It can also access the Docker environment because I did a volume mapping to my Docker host. And therefore, I can do the entire build and release pipeline in VSTS. But I still use the Docker environment in my local data center or on my developer box. Okay? That's the idea. And hopefully it will work. Now let's take a look at the build process that I prepared for you. Very simple. Nearly just the auto-generated build process, but let's take a look. I just added one or two things. I will point them out. Here you see the process. Very simple. It does a .NET restore, it does a .NET build, and it does the .NET publish. This is exactly the .NET stuff that you are used to do. But this time, it's publishing, building, and restoring the stuff inside of my Docker container, not in the hosted VSTS agent provided by Microsoft. And additionally, I prepared a small Docker file that we can use. You've seen the Docker files already. If we take a look at the publish step here, then you will see that I added here the architecture switch. Can you remember what the architecture switch was? It was the thing with the self-contained deployment stuff. So I can use the smallest possible image to publish my application, my .NET application. This is what I want here. So I publish this 500 something files as the result of my build step. Okay, let's queue a new build. It is a release build. Here it is the release build, and I'm using the agent queue default. Can you remember? The default agent queue was the queue that my local build agent has subscribed to. This is how I have set up my machine. Okay, let's see. If the demo gods are smiling, and my internet connection is fast enough, we have 5 minutes left, that's fine. Yeah, we should see the console. This is now running on my local machine, so it's running inside of this guy here. The first thing is it does a .NET restore, so it's fetching a bunch of NuGet packages. Now it does the build. I zoom in a little bit, and you can see it. The white screen is just because my internet connection is so slow, so we see the logs, but it's already done. You see, no warnings, no errors. This is exactly what we want. And the publishing step is now creating the Linux files. This is the SCD directory that you have seen before. There's 500 something files. And instead of waiting, I can do the following. I can show you one of the previous builds that I did. It looks like this. This is the publish step. The important thing is that it's creating a folder, Linux x64, and inside of this folder, it puts all these 500 files and so on, and these files are then pushed, it's 526 files, are then pushed into the artifacts of the build. So the result of the build, if we take a look at this build here, contains our Docker file and our self-contained deployment. So this is the result of our build. We have used Visual Studio Team System build, but our own build agent inside our Docker container, and we didn't have to install .NET SDK, all the things. It's all embedded inside of this VSTS agent. And the VSTS agent container was talking to VSTS, and the whole artifact stuff and scheduling stuff is all done in the cloud. We don't have to care for that. I really like this environment, this setup. Let's see if our latest build is now successful. It will probably take a while because uploading all this DLLs through my wireless connection here will not be the fastest one. Yeah, you see it's currently publishing the artifacts for 1.5 minutes, something like this. I will not wait. You've seen the result. What I want to show you in the last few minutes is the release part, because I have also created a release definition. Let me show you how that looks like. This is VSTS release management. Nothing special, nothing to do with Docker, but inside of this release definition, we definitely have some Docker stuff going on. So I've created a release management definition here where I now use the result of the build and create a Docker image from it. But the Docker image creation is not running somewhere in Microsoft's infrastructure. It's running in my data center, on my machine. And it's talking to my Docker host and my trusted registry. It's all done inside of my network. And this is very important for a lot of customers, that the source code will not leave my environment, or at least the build results and things like that. It's all done in my environment, so I can access all the artifacts that I need that maybe live in my own data center. Okay, that's the important message here. And the second thing is I'm also pushing the image to the Docker Hub. So in that case, I'm pushing it to Docker Hub, but you can also push it to your own trusted registry. And from there, your admin guys can pull your Docker image and run it on your production or test Kubernetes cluster, for instance. So the point of this demo is use VSTS, use build agent, use the build infrastructure, the release management infrastructures, but if you want, you can use the container, the ready-made image, Microsoft VSTS agent, and spin up the build agents on your laptops, on your servers, or wherever. So you have the best of both worlds. A configurable build agent, where you can add your own customizations, and platform as a service and ready-made images for your .NET stuff. Okay? So let's... Yes, I know. Give me one last minute. So, click. I want a green check just to prove that it really works. And I want to see green, please. It's still in progress. Okay. It's nearly green. It will become green in a few seconds. So, you've seen nearly all demos, but please, excuse the last demo not running completely because of the wireless LAN issues. With that, I'm out of demos. Will you get the slides? Yeah, definitely. So I will hand over my slides to the conference organizers. And what I've done inside the slides, you cannot really read the blue links on the green background. Doesn't matter, you will get the slides. You will see the important Docker images. Just click on the slides, you will get to Docker Hub, and you can read all the details, how you can use it. And here I also linked the entire samples that I showed during this talk. Feel free to get them. They're all MIT licensed. Take a look in my GitHub repos. You will see lots of slides and Docker intro slide decks, workshop materials. Everything is MIT. Take it, use it, share it, send me pull requests, give it stars, whatever you want. And 2 important links to the Microsoft documentation if you want to read more. Microsoft already has very detailed documentation of this stuff. I hope, although we had some wireless LAN issues, it was an interesting session for you. I hope it was an interesting format with doing mainly demos and only a few slides. I say thank you for coming to my session, and please give me evaluations. I'm looking forward to hear whether you liked my session or not. If you have any questions, please come to me after the session. I'll do my very best to answer them. Thank you for coming. Have a very nice day.